Hi, this is another demo video of some more complex urban propagation analysis using EMSlice. So to start with, I'm going to drop the same street map file into the start window and we get the new system dialog, and again we want to accept the default parameters. And again, if we add a base station to the center, we get a heat map generated. But this time we want to look more closely into the propagation paths that are being calculated. So to do that, I want to edit the city parameters and change the rendering from heat map to TXRX propagation path. Now all rays will be hidden because there's no receiver present in this model at the moment, but if we add a receiver, we'll see the multiple propagation paths that have been calculated. I'm going to move that receiver now to around the corner here so that there is no direct line of sight path from the transmitter to the receiver that's been calculated. And for simplicity's sake, I'm going to reduce the number of reflections to 2. Now I want to calculate what the diffracted path would be if we were to consider diffraction at this corner. So if I turn on diffraction, this then recalculates and we end up with 2 rays that diffract at this corner, and so at this corner we end up with a diffraction source, and from that source we have 2 diffracted paths that arrive at the receiver. Now to look into this effect more closely, I'm going to remove this model and start another in a much smaller and simpler environment. But this time I'm going to do the modeling in 3D, and I want to start by drawing results as the TXRX propagation path. So now we have a far simpler system, a smaller area with only a handful of buildings to consider. And in this system I'm going to add a receiver to the far side of this building, and add a transmitter on the near side of this building. You'll see that we only have found one propagation path, which includes multiple reflections. This is because, to start with, the propagation parameters only allow for reflection. So I'm going to reduce the reflection limit to 3 and now enable 2 diffractions and recalculate. This will allow us to detect propagation paths that go around the corners and over the top. You've noticed that we've picked up many propagation paths now, so those that diffract off the top and around the edge, but none that go directly off the top and down the far side. So by reducing the ray gap, we effectively send out more rays, which allows us to detect more diffraction points, and so to give us a more accurate result. This may take a moment to calculate, so going to pause recording for a moment. So now that calculation is complete, you can see that we have a propagation path that goes over the top of the building, directly from the transmitter, as well as from the transmitter off the floor and to the top, as well as around this side and around this side, and again towards the corners. Now I'm going to change these two view areas, one to be direction of departure, which shows us where all the rays, the direction of the rays that have been sent from the transmitter that have arrived at the receiver, and I'm going to change this side to the direction of arrivals, which shows the direction that received rays at the receiver have been received from. This kind of analysis lets us consider in more detail the different propagation effects and mechanisms that impact the accuracy of various radio technology systems. Next I'm going to run another model on a larger area. So this street map file is a large area, and so I'm modeling in 2 dimensions again. For this example, I want to change the scenario to model in to show the transmit receive path, and to increase the ray gap to 5, and then transmit the reflect limit to 2 just to start with. And then if I add a base station alongside one of these buildings, there's no receive path. Okay, I'll change that to show all rays, and then we'll see where the radiation has propagated to. So this is with only 2 reflections and a 5-degree ray gap, and so we get very little propagation between buildings has been detected. If I change that to 2-degree ray gap and I allow 3 reflections, you'll see far improved propagation coverage, but we still don't get into a lot of these finer positions. So I'm now going to enable diffraction and allow 2 diffractions and choose a ray gap of 1 degree and apply again. This recalculation will take a moment because there's more processing to be done, so I'm going to pause recording until it's complete. So now that that's complete, we see that the propagation paths on the propagation calculation has gotten into far more side streets and alleyways within this environment. And so by allowing multiple diffractions and reducing the ray gap, we get a higher accuracy simulation or ray tracing simulation through this scenario. For more detail on EMSlice capabilities and what other functions we can perform, see emslice.com, and thanks for watching.